All right, boys and girls, I need to talk fast because this is going to be a long video, so I'm going to dive right in. Today we're going to focus on multiplying decimals. It's the same but different. And we're going to find out that multiplying decimals is a two-step process. We're going to focus on step one first, then we're going to stop the video, do some practice with step one, and then we'll move on to step two, put it all together. So what is step one of multiplying decimals? It is playing pretend. So hopefully at some point in your life you've liked to play pretend. You're going to get to do that today. Let me show you what I mean. Step one in multiplying decimals is playing pretend. What that means is you are going to pretend that the problem has no decimal points. To do that, you're going to rewrite the problem without any decimal points in it, and then solve it as if it's not decimal numbers, it's just whole numbers. So let me show you what I mean here. Instead of 6 7/10, we're going to pretend that it is just the number 67. And instead of 0 8/10, we're going to pretend the number is just 8. And so instead of 6 7/10 times 8/10, we're going to solve the problem 67 times 8. And this is why we've been practicing multiplying whole numbers. 8 times 7 is 56. Put the 6 down, carry the 5. And 6 and 8 went on a date. 6 times 8 is 48. Plus 5 more is 53. So step one of multiplying decimal numbers is to play pretend. Pretend there's no decimal points in the numbers. Rewrite the problem and solve it like they're whole numbers. Let me give you a different example. Again, we're going to be multiplying decimals, and to do that, step one is to play pretend. Pretend the problem has no decimal points. We're going to rewrite and solve. So instead of 14 5/10, we're going to take that decimal point right out and pretend it says 145. And instead of 9, if I take a decimal point out, there is no decimal point, it is still 9. So we're actually going to pretend that this problem is 145 times 9. So I'm going to set that problem up over here, and I'm going to solve it the way we've been practicing multiplying whole numbers. 9 times 5 is 45. Carry the 4 over to the tens place. 9 times 4 is 36, plus 4 more is 40. Put the 0 down, carry the 4. And 9 times 1 is 9, plus 4 is 13. So step one of solving a multiplying of decimal problems is simply to play pretend. Now we're not done yet, but there would be a step two, but that is step one. Let's look at another one. Shows you just how easy this could be. Step one is playing pretend. We're going to pretend there's no decimal points. We're going to rewrite the problem and solve it. So instead of 6/10, we're going to pretend this is just the number 06 without the decimal point, which in reality is just the number 6. This is 7/10, which would just be the number 07, which really means the number 7. So what this problem would actually mean if we're playing pretend is we're going to take 6 and multiply it by 7. 6 times 7 is a quick multiplication fact, 42. Let me give you another example of step one, playing pretend. We're going to rewrite and solve the problem without any decimal points in it. This will become just 53, not 5.3. We'll pull out the decimal of 2 9/10, and it'll become 29. And instead of 5 3/10 times 2 9/10, we're going to solve 53 times 29. So I'm going to do that over here. We have 53 times 29. I'm going to go ahead and use the standard algorithm here. 9 times 3 is 27. Carry the 2. 9 times 5 is 45, plus 2 is 47. I'm going to go ahead and cleanse the 9 and anything the 9 made and throw that 0 down here so we can move to the 20. 2 times 3 is 6. 2 times 5 is 10. And I'm going to end this problem, or the step of this problem, by adding our partial products here. 1 plus 4 plus 0 is 5. And 1. So right now I finished step one. There would be a second step. We're not going to do that quite yet. Last example, we're going to go ahead and rewrite and solve and pretend the problem has no decimal points. This 9/10 would really just be 9, and this 32 hundredths would really just be 32. And when I multiply these two numbers together, what I need to remember is when I'm multiplying whole numbers, I can change the order, and we always want to put the number with more digits on top. It just makes it easier to solve. So 32 times 9 is going to look like this. 9 times 2 is 18, carry the 1. And 9 times 3 is 27, plus 1 is 28. So again, I just went through and I just pretended. I got to play pretend that these problems have no decimal points in them. They simply are whole numbers that we're multiplying together. This will allow us to get the digits that are part of the answer. The second step, we'll be worrying about that decimal point. So at this point, I want you to stop, actually hit pause on the video, and you're going to go to the next part of the worksheet that says step 1, playing pretend. For this one, I only want you to practice step 1. So I want you to rewrite the problem without any decimal points in it and solve it as if they're not decimal numbers, but they're whole numbers. That's step 1 of multiplying decimals. You are going to do these 6 problems as a 1, 2, 3 check-in. These directions are on the sheet as well, so go to the worksheet where you left off and try just step 1. Give it a shot. All right, boys and girls, it seems like you've done really well with step 1, but multiplying decimals is not a one-step process. It is a 2-step process. Step 1 was playing pretend. We pull out those decimal points. We pretend that they're not decimal numbers. We pretend that they're whole numbers, and we rewrite the problem without the decimal points and solve them. Step 2 worries about that decimal point. We need to put that decimal point back into the answer where it belongs, because there needs to be a decimal point in the answer. If there's a decimal point in the problems, we must have a decimal point in the answers. So step 2 is to add the decimal. There's a very simple rule for placing the decimal in the answer. I'm already kind of showing you step 1, and I'm just going to now model step 2. The rule is simple. You're to count however many digits live in the decimal thuniverse in both of the problem's factors. So the numbers we multiply together are called factors. We are going to start by counting how many digits live in the decimal thuniverse in the problem. And then that number has to be the same number of digits living in the decimal thuniverse in our product, in our answer. So we know when we did step 1, we got the digits 536. We know that's not the answer. I can tell you that's not the answer by doing a quick estimation. I know 6 and 7/10 is about 7. I know 0 and 8/10 is about 1. And I know 7 times 1 is 7. That is nowhere close to 536. I know I need to put a decimal point in here. You could probably guess where it goes based on the estimate, which is why estimating is so important. But let me show you the rule. So it says count however many digits live in the decimal thuniverse in the factors. So in 6 and 7/10, we have 1 digit living in the decimal thuniverse. In 0 and 8/10, we have 1 digit living in the decimal thuniverse. So together, between both, we have 2 digits living in the decimal thuniverse. When we put the decimal point into our final answer, we need to have 2 digits living in the decimal thuniverse. So in order to make that happen, I need to put the decimal here, and that will give me the 2 digits living in the decimal thuniverse. You can see that this makes sense with my estimate. 7 is close to 5 36/100. If I had put the decimal anywhere else, if I had put the decimal here, for example, that would have given me 53 6/10, and 53 is nowhere near 7. So definitely my estimate makes sense with where I put my decimal point. Let me show you another one. We need to make sure we count however many digits live in the decimal thuniverse in our factors, which are here. And that number has to equal how many digits live in the decimal thuniverse in our answer. So I'm going to do a quick estimation. I know 14 and 5/10. I'm not going to show my work because I don't want to write all over the problem, but 14 and 5/10 rounds to 15. And of course, 9 is a whole number that rounds to 9. I will be honest, I don't know what 15 times 9 is in my head, so I can just do a quick little problem off to the side. 9 times 5 is 45. And 9 times 1 is 9 times 1 is 9, plus 4 is 13. So I know that my estimate's going to be about 135, which if you look at where I am with my answer right now, they're not even close to each other. It's because I'm missing my decimal point. To figure out where my decimal point goes, I need to count how many digits are living in the decimal thuniverse in the problem, and that has to match the answer. So I can see in 14 and 5/10, I only have one digit living in the decimal thuniverse. In 9, I don't have any digits in the decimal thuniverse. So all together, I just have one digit, because I don't have any there. I just have one digit living in the decimal thuniverse. When I put my decimal point into my answer, I need to put it in a place that will also give me one digit in my decimal thuniverse. In order to do that, I need to put it here, and that will give me one digit in my decimal thuniverse. And you can see my estimate is now really close to my actual answer. Let's do another example here. We're going to count how many digits live in the decimal thuniverse. Well, in 0 and 6/10, we have the 6 living in the decimal thuniverse. In 0 and 7/10, we have the 7. So altogether, I have 2 digits living in my decimal thuniverse. When I go to put the decimal, that's step 2, is placing the decimal into my answer, I need to make sure that there's also 2 digits living in the decimal thuniverse. If I put my decimal point here, that only gives me 1. In order to do that correctly, I'm going to need to put the decimal here. That will give me the 2 digits in my decimal thuniverse, which means I don't have anything in my whole number place value. So really, my answer would be 0 and 42/100ths. To see if that makes sense, 0 and 6/10 is about 1, 0 and 7/10 is about 1, and 1 times 1 is 1. 1 is really not far from 0. Definitely close to my estimate. Couple more here. We're going to count the number of digits living in our decimal thuniverse in our original problem. We have the 3 in 5 and 3/10. We have the 9 in 2 and 9/10. So all together, I have 2 digits living in the thuniverse here. I need to make sure that in my final answer, where I got 1537 in the pretend step, I make sure that I put the decimal point where there are 2 digits, in this case the 3 and the 7, living in the decimal thuniverse. A quick estimate, this is about 5 and 3/10. 2 and 9/10 is about 3. 5 times 3 is 15. Man, oh man, were we close to our estimate when we put our decimal point in our actual answer. Last one, counting the digits in my decimal thuniverse. I have 1 from the 9/10, and I have 1, 2 from the 32/100ths. All together, that's 3. 1, 2, 3 digits living in the decimal thuniverse. So in my answer, I need to put the decimal point where there are 3 digits living in the decimal thuniverse. If I put it here, that only gives me 2, the 8 and the 8. I need to put it here, which gives me 1, 2, 3 digits living to the right of the decimal point, which is the decimal thuniverse. My estimate would be about 1 times 0, which is 0, which, what do you know? If I have nothing in my whole number place value, that's pretty close to 0. At this point, you're done with the video. So you're going to go ahead, you're going to stop, you're going to put your computer away, log out of it first. You're going to go back to the worksheet and follow the next step. It says step 2, place the decimal. You're going to go back to the work you did in step 1, where you pretended that they were whole numbers and got the digits for the answer. Now you're going to go back, count the digits in the decimal thuniverse in order to place the decimal in the correct spot. Okay, you are going to do this again as a 1, 2, 3 check-in. You've already estimated, if you go to the front of the page, you've already estimated for all of these questions. You can always go back and check your estimate, just like we did in all of our examples here, to see if where we placed the decimal really got us close to the actual answer when we did our estimate. So that's what you're going to do for your next step. Again, you're done with the computer. You're going to go ahead and stop, put it away. It's always here as a resource if you need it in the future. And you're going to do wonderful. If you have any questions, make sure you check in with a teacher.